Hello, welcome to Digital Tutorials. I'm Mr. Collins. I'm going to take you through matrices today. Just a brief introduction on matrices. We'll learn the different terms that are used in matrices, the order of a matrix, and also we'll learn how to perform different operations on the matrices. We'll also conclude by going through some of the properties that we draw from the operations of a matrix. Welcome. If you like our video, please you can hit the subscription button. Leave a comment there if you have any questions and I'll get back to you immediately. Now, on a brief introduction, we will want to know what is a matrix. What do we call a matrix? Now, a matrix is an ordered rectangular array of numbers. We usually enclose that matrix in a parenthesis, sometimes known as brackets, but it's a parenthesis. Then we denote a matrix using a capital letters. Like if it's matrix A, we denote using capital letter A. If it's matrix B, you denote using capital letter B. Another term that is used is a zero matrix. Now, this is a matrix that has zero entries, that all the entries are zeros. It means that if it's a 2 by 2 matrix, that it has 3 rows, 3 columns. Everything in those columns and rows are zeros. Another term is a square matrix. This is a matrix that has the same number of rows and the same number of columns. The number of rows is the same as the number of columns. Like a 2 by 2 matrix, it means that it has 2 rows and 2 columns. A 3 by 3 has 3 rows, 3 columns, etc. Another term is an equal matrix. We say that matrices are equal if they are of the same order and the corresponding entries are equal. An equal matrix also, we can also say that matrices are of the same size. That it will be meaning they are equal. Another term is a row matrix or a row vector. This is a matrix that has only one row. Now, it means it can have different a certain number of columns, that is n columns, but it has only one row. Which is the other way around for a column matrix. It means that it has only one column, but it can have n rows, a certain number of rows. Now, the order of a matrix is the number of rows and column in that order. For example, an m times n matrix, it means that it has m rows, n and n columns. Examples of the orders of different orders of a matrix, for example, is a 2 by 2 matrix where we have 2 rows and 2 columns. Then 3 by 3 matrix also it has 3 rows and 3 columns. 3 rows and 3 columns. 2 by 3 matrix is a matrix that has 2 rows and 3 columns. Same thing with the 4 by 3 matrix. It has 1, 2, 3, and 4, and 3 columns. That is 1, 2, 3. And this one is a 2 by 1 matrix. It has 2 rows but 1 column. So we call it a column matrix or a column vector. Now, let's now identify the different elements of a matrix. Now, a general matrix is of this order. This is a matrix of m times n. For the first row, it is A11, A12, up to where A1n. N is representing a certain number. It can be any number in that order. So these are the first row. The first number for A11, this first number 1 represents the row. It means it's on the first row. The second number 1, it means it's on the second column. So this is our first row and this is our first column. Now the column, it ends at M1. M represents, it will be any position whereby the any number and number of columns that will be there, the number of rows that will be there, that is our mth column. Now the other is the second row. The second row is this one, and our second column is here. Together, this is our nth column and our mth row. Now, We said earlier that a matrix is usually enclosed in a parenthesis. Now this is our parenthesis. It's enclosing our M times N matrix. We denoted this matrix with capital letter A. It's matrix A. Matrices are arranged into rows and columns. That is, it's arranged in number of rows, number of columns, times the number of columns. That is, this how you also write the order of a matrix. The number of rows multiplied by the number of columns. For example, if this matrix was a 3 by 3 matrix, it will be 3 rows, 3 columns. We can also represent a matrix as Aij. This matrix here, we can represent it as Aij. A is our denotation for a matrix, as we said earlier in the definition. And Aij that is enclosed in a parenthesis here, it means that A is our entry, I is the rows, and then J is the columns. Now, when there are different operations to perform in matrices, one of them is the addition. Now, for matrix addition, it can only be done on matrices of the same order. You cannot perform matrix addition on matrices of different order. So if it is 2 by 2 matrix, you can only add it to a 2 by 2 matrix. You cannot add a 2 by 2 matrix and a 2 by 1 matrix. Same thing with subtraction. Subtraction also is performed on matrices of the same order. Now, there's a uniqueness in the operation, in matrix operation on matrices. Now, matrix operation does not depend on order. It does not rely on order. You can perform matrix multiplication on matrices of different order. But this one we will discuss in our next video, whereby we will look into matrix multiplication, where we multiply matrix with a scalar, and also we multiply matrix with another matrix. Today we are only going to look at addition and subtraction. Let's look at different examples and see how. Given matrix A as 6, 3, 4, 2, matrix B as 2, 1, 9, 4, and C as 3, 7, 4, 5, we have been asked to find A plus B. It will be 6, the number on the first row, first column for matrix A, plus the number on the first row, first column for matrix B. That will be 6 plus 2. You get 8. 3, the number on the first row, second column, plus the number on the first row, second column on B. That will be 3 plus 1. You get 4. Same thing, second row, first column, that will be 4 plus 9. You get 13. 2 plus 4, 6. We've also been asked to find A plus C. That will be 6 plus 3. You get 9. 3 plus 7, 10. 4 plus 4, you get 8. 2 plus 5 is 7. Then for B minus C, it will be 2 minus 3, you get negative 1. 1 minus 7, you get negative 6. 9 minus 4, you get 5. 4 minus 5, you get negative 1. Other examples are A minus C. A minus C, it will be 6 minus 3, you get 3. 3 minus 7, you get negative 4. 4 minus 4, you get 0. And then 2 minus 5, you get negative 3. Also, C minus 8 will be 3 minus 6, you get negative 3. 7 minus 3, you'll get negative 4. 4 minus 4, you get 0. And then 5 minus 2, you get 3. And this will be the end result on the matrix. The last one is matrix A plus B minus C. Now, you just do as we did earlier in the other examples, that you take the first row, the first column, you add. So, because you are dealing with addition and subtraction, it will be 6 minus 2, 6 plus 2 minus 3. That's the number on the first row, first column for each of the matrices. That will be 6 plus 2 minus 3, you'll get 5. 6 plus 2 is 8, then minus 3, you get 5. Now, another thing here is that you follow the order of operations, that is the BODMAS. You apply BODMAS for you to solve that there. You also have 3 minus 7. 3 minus 7, 3 plus 1 minus 3 plus 2 minus 7, sorry. Sorry, it's supposed to be 3 plus 1 minus 7. 3 plus 1 is 4, minus 7 should be negative 3 here. Also, we have 4 plus 9 minus 4, you get 9. 2 plus 4 minus 5, that will be 6 minus 5, you get 1. We have also been asked, we have been given four matrices also, that is A, B, C, and D. For A and B, it's a 2 by 2 matrix. For C and D, it's a 2 by 1 matrix. So we have been asked to find A plus B. A plus B will be 10, first row, first column, plus 16. Get 26. 2 plus 25, 22 plus 25, you get 47. 13 plus 13, you get 26. 9 plus 11, you get 20. The end result when adding 2 by 2 matrices, if you have noticed from the other examples, is that when you add matrices of a certain order, it will give you a matrix of the same order. In this case, it has given us a 2 by 2 matrix. B plus A, it will be matrix B plus A. It will be 16 plus 10, you get 26 again. 25 plus 22, 47. 13 plus 13, you get 26. Then 11 plus 9, you get 20. If you have noticed, our answers, our end results from matrix from Roman 1 and Roman 2, it is the same. That shows us that even if we interchange matrix in addition, it just gives us the same matrix. That is A plus B is the same as B plus A. Now, matrix C plus D, you have the 2 by 1 matrices. That will be C plus D. 32 plus 8, you'll get 40. 17 plus 4, you get 1. Another example is you have been asked to find A plus B and B plus A. Find A plus B, B plus A, B minus A, and A minus B, where A you have been given as negative 4, 3, 2, 8, 6, 0, negative 2, negative 8, 4. This is a 3 by 3 matrix. We are being asked to perform on matrix B, which is also a 3 by 3 matrix. That is 8, negative 2, 6, 6, 1, 3, 9, negative 4, 9, negative 2, 4. So for A plus B, we just do as we did on the 2 by 2 matrices. You take the number on the nth row, nth column, you add the number on the nth row, nth column. That will be negative 4 plus 8. You'll get 4. 3 plus negative 2, you'll get 1. 2 plus negative 6, you get 4. That will be 2 plus negative 6 will be 2 minus 6. That is the integer operations, that is negative and positive, it becomes a negative. The same thing applies on all the other rows and columns, and when you perform, you'll get the matrix that looks like this. It's a 3 by 3 matrix also. We have also been asked B plus A. For B plus A, it will be the same. It will be 8 minus 4, you get 4. Negative 2 plus 3, that will be 1. And also when you do on the other rows and columns, you'll get the same matrix as the other one that we got on the earlier slide. This proving to us that matrix A plus B is the same as matrix B plus A. For A minus B, you'll take negative 4 minus 8 to get negative 12. 3 minus negative 2, that will be 3 plus 2, you'll get 5. 2 minus negative 6 will be 2 plus 6, you get 8. 8 minus 6, that will be 8 minus 6, you get 2. 6 minus 1 to get 5. 0 minus 3, it will be negative 3. Negative 2 minus 9, it will be negative 11. Negative 8 minus 2, you get negative 10. And then negative 8 minus negative 2, it will be negative 8 plus 2 to get negative 6. Then 4 minus 4, you get 0. The same thing for B minus A. When you subtract B minus A, you get a matrix that is quite different from the matrix A plus B. You see that where there is a negative on matrix A minus B, it is a positive on matrix B minus A. That means that when you subtract A minus B, it will be the negative of B minus A. So this shows that matrix subtraction is not commutative. Now, speaking of that, we can draw the different properties of matrix operation. The first one, that's where we did A plus B is equals to B plus A. That shows us that matrix addition is commutative. If you take matrix and you rearrange the order of how you add them, you still get the same answer. Matrix addition also is associative. That is from three matrices A, B, and C. If you add them together, you add matrix B and C, then you come and add matrix A later. It will be the same as just adding matrix A and B, and then you add C later, or adding matrix A and C, and then you add B later. That shows us that it's associative. You can interchange for matrix addition. For subtraction, you cannot be done that way. It will give you different answers. Now, we also say that the identity matrix exists. The identity matrix is a matrix with zero entries, as we had discussed the zero matrix. The zero matrix is the identity matrix. That is, it has zeros in all of its entries. That will be matrix A plus the zero matrix to just be that 0 plus A, which will just give you the same answer, the same matrix A. We have come to the end of our video. Thank you so much for watching. If you like our content, please subscribe, like, share to your friends and relatives. Tell them to come here and see what we've got for them in store. Feel free to post any questions in the comments, and I'll be happy to assist you in any way I can. I'll be ready there to reply on your comments. Thank you. See you in the next video.